Welcome to The Explainer. You know, every single one of us running applications knows that feeling, right? You've got to perform essential maintenance on your cluster, but taking the app offline, even for a minute, that's just not an option. So today, we're going to dive into the Kubernetes feature that's designed to solve exactly that problem.
Okay, so here's our game plan. We'll start by really digging into the problem with the downtime dilemma. Then, we'll introduce our solution, the Pod Disruption Budget, or PDB for short. After that, we'll see it in action, talk about why it's an absolute must-have in a multi-cloud world, and finally, we'll get to the good part, what it feels like to achieve true zero-downtime maintenance.
So let's set the stage. We're talking about planned maintenance here. You know, things like node upgrades or rolling out a critical security patch. These are all good things you have to do, but they often come with a really high cost.
So I want you to ask yourself this question right now. If you had to drain a node for an urgent upgrade, would your application survive? I mean, would it really stay online, serving users without a single hiccup? For a lot of us, the honest answer is probably, I'm not so sure. And that uncertainty, that's exactly what we're here to fix.
Because this is the alternative, isn't it? The dreaded 503 service unavailable. And let's be real, this isn't just a technical error. This is a frustrated customer, it's lost revenue, it's a hit to your reputation, and it's a frantic page to the on-call engineer in the middle of the night. This is what happens when maintenance goes wrong.
But it doesn't have to be that way. It's time to meet the hero of our story, the Pod Disruption Budget. Seriously, think of it as a powerful insurance policy for your app's availability, and it's built right into Kubernetes.
So what is it, technically? A pod disruption budget is a native Kubernetes feature. Its one and only job is to limit how many of your application's pods can be taken down at the same time during what we call voluntary disruptions. And that's just a fancy term for the node drains and updates we've been talking about.
And this right here is my favorite way to explain it. Just forget the tech jargon for a second. A PDB is basically you laying down the law. You're telling the Kubernetes cluster, look, I get it, you need to do your maintenance work, and that's cool, but, and this is a big but, under no circumstances are you allowed to drop below this minimum number of running pods for my application. It's really that simple.
Now the difference here is just night and day. On the left, without a PDB, you've got chaos. An admin starts a node drain and Kubernetes just starts ripping through pods, maybe even taking your entire app offline all at once. But on the right, with the PDB, you get control. Kubernetes sees your budget and says, well, hold on, I can only evict one pod at a time because I have to respect the rule to keep a minimum number running. It completely transforms maintenance from a risky gamble into a controlled, predictable process.
Okay, so that all sounds great in theory, right? But how does this actually work? Let's get our hands dirty and walk through setting one up for a standard web app. You're going to see just how easy this is.
It's really just 3 simple steps. First, you use a selector in your PDB manifest to tell it which app it's supposed to be protecting. It just matches the labels on your pods. Step 2, you set the budget. This is where you make the rule, usually with min available, to say how many have to stay up. And third, you just apply that manifest to your cluster with a quick kubectl apply, and boom, your availability insurance is now active.
Okay, this is super powerful for a single cluster. But how does this idea scale? Because in the real world, our apps aren't just living in one little corner. The challenge is keeping this level of resilience everywhere.
I mean, your applications are probably deployed all over the place, right? You might be running on Amazon's EKS, maybe Microsoft's AKS, and Google's GKE. So how do you make sure your high availability strategy is consistent and doesn't need a totally different setup for each cloud?
And here is the absolutely beautiful answer. Because the Pod Disruption Budget is a core, standard part of the Kubernetes API, it works exactly the same everywhere. The same PDB manifest you write for your cluster on-prem is the exact same one you apply to EKS, AKS, and GKE. No vendor tweaks, no special configs, just pure, portable Kubernetes resilience. This is a massive, massive win for multi-cloud.
So let's bring it all together. We get the problem, we've put the solution in place, and we've confirmed it works across our entire cloud footprint. So what's the final result? What's the payoff?
This is the dream right here. The node upgrades are done, the security patches are applied, and not a single user even noticed. The PDB stood guard the whole time, gracefully pausing pod evictions to make sure the minimum number of replicas were always serving traffic. The application stayed 100% available.
So what should you take away from all this? First, downtime during planned maintenance is now a choice you make, not something you just have to accept. Second, Pod disruption budgets are your simple, powerful guarantee for high availability. And finally, you can apply that same guarantee consistently with the same standard across any major Kubernetes platform you use.
So, putting a PDB in place is a huge step towards a truly resilient system. But it does leave us with one last, really critical question to think about. You've made sure your application logic stays online, but what's protecting your stateful data during these same disruptions? We'll leave you with that thought. Thanks for watching.